Welcome back to the Data Management Practices track. I'm still Aldis Carlos Karlovskis. I'm the founder of Techies of Baltics movement. Check that out. Greetings from our knowledge partner Pact. They will give away some ebooks for the to the most active attendees. So rate sessions, leave comments, ask questions, and get a very nice ebook. So for our second talk, we got solutions architect Robert Hoffmann from Amazon Web Services, who's gonna try to change the world by getting rid of YAML and JSON files. So over to you, Robert. Tell us, what do you know?
Yeah, thanks a lot for that intro. Hi, everyone. Um, so, in fact, at least I would like to change my world. Um, this talk is called Stop Configuring Infrastructure, Start Coding It. And that's what I did for me. And the reason for that is, and I have to make a confession here, I'm pretty afraid of all that YAML and configuration language files we have to write to provision infrastructure. That can be tons and tons of files, and really have nightmares about this. So an alternative title to that talk could be How Coding Infrastructure Helped Me to Deal with My YAML Phobia. And maybe you have YAML phobia as well, and I can help you to overcome this. But before I dive deeper into that, let's start at the very beginning and talk about how infrastructure provisioning has changed over the history of wherever and whenever you started doing it. So if you were around in the dark ages of infrastructure provisioning, you did everything manually. So you had some wikis, you had some playbooks, and you had this one person who knew everything. And when something broke, you were praying that he or she wasn't on holiday or has already left the company. Then you started to script everything. So you had a lot of bash scripts, and these bash scripts would then configure infrastructure, install things, update things, and so on. And that mostly worked unless it didn't, because some of the scripts broke because the state was different or something like that. Then we had a kind of a revolution, which was the declarative approach to provisioning infrastructure with things like AWS CloudFormation or the very well-known Terraform, where you would basically write a configuration file in YAML or some other domain-specific language, and that file would represent your infrastructure, and you would give it to that tool and tell the tool, please make the world like I want to have it, like it is described here, create VMs, install things, get databases, and whatever I can do in my cloud. And that's basically where my journey started. So some years back, I was transitioning into a new role as an architect. And I knew in that role, I would do a lot of stuff on AWS. And also I knew that I would probably on a daily basis work with declarative provisioning of infrastructure with CloudFormation. So I thought, okay, I did this from time to time, but I really didn't do it a lot. So let's jump back in and find out how it works, how it feels, because that will be an important part of my job. And I want to know if that's the right thing for me. So I challenged myself with a very simple architecture that we can see right here. So all I wanted to do is a highly available web application that I can call from the internet. And to do that, we basically need two things mostly, which is an Amazon EC2 autoscaling group. So that's a group of VMs that runs my web application. And that web application really is just one HTML file. And then we have an AWS application load balancer who is taking requests from the internet and is then distributing them among a number of VMs in that autoscaling group. So if one of those VMs goes down, it would still work because it could send the traffic to another one. So I thought, hey, this is super simple, right? This should be easy. So let's write this in the native declarative infrastructure as code tool from AWS, which is AWS CloudFormation. And this is how it looks like. It's a lot of YAML, basically. And this is where my nightmare started. So on the one hand, I got a CloudFormation template, which is the native infrastructure definition for AWS. It was fully declarative. The IDE support was like hit and miss. So some things worked, some didn't. It really depends on what IDE you're using to write these things. But what really scared me was this part here. It was actually over 300 lines of YAML that I had to write for this simple thing. And I was mildly surprised by that. So what's going on here actually? And to answer that, we have to zoom in a little bit. So now we're seeing what's actually behind all these resources, or behind this very simple diagram that I showed before. So it looks easy on the outside, but in the inside, there's actually a lot of stuff to configure. And that's the reason why you get to over 300 lines of YAML, even for such a simple architecture. So what do we actually need? So one thing we didn't even see in my first diagram, which is the VPC, the virtual private cloud. That's basically your private network in the cloud that's only there for you and for your applications to deploy in. Now, it's not enough to just create this VPC somehow. You have to configure and think about a lot of things. So you have to think about availability zones, which are those multiple dedicated data centers AWS has per region. And you want to run your network in all of those availability zones, or at least multiple, to be highly resilient against failure. Then you have to think about all the IP address ranges and how to cut subnets from them. And then you have to think about internet connectivity with internet gateways or NAT gateways. And then to make everything work, you also have to think about route tables, because those subnets need route tables, which tell them what is connected and how, for example, to get out to the internet. And that was just the VPC. So if we look at the application load balancer, there's also a lot of stuff to configure. Like, for example, what port is the load balancer listening on, and what security groups do you want to have? So security groups are kind of the built-in firewall of the load balancer. And same thing goes for the autoscaling group over here. So we have to define what kinds of VMs we want to have, what kind of EC2 instances. We need to define what machine image we want to use for our operating system. We also have to define security groups, and we have to define how to scale the whole thing. So in summary, there's a lot of stuff you have to configure to basically fulfill this very simple architecture. And that's where those 300 lines are coming from. And after that experience, I was actually a little bit scared and not so happy. So of course, what do you do in that case? Well, you go out drinking coffee with a good colleague, and I told him about my dismay, and he said, "Well, Robert, I heard of something that might be right up your alley. I know you were a web developer before, so you have some experience with JavaScript and TypeScript. I heard of this thing where you can actually use programming languages to declare your infrastructure, and not that YAML stuff anymore." And I was like, that sounds too good to be true. Is that real? And he came close and basically said, "Robert, imagine there's a world where before you did it manually, and you had to be a lucky engineer, lucky that it works. Then you were doing it in a scripted way, and you were a bash engineer. Right now, you're a YAML engineer because you're doing it declaratively. And in the very near future, maybe you can use software and abstraction and be a software engineer and build your infrastructure. Wow. Let's see how that works. So in the recent years, there are a number of frameworks which are trying to abstract infrastructure with general purpose programming languages. You can see two pretty popular choices here. So there's the Cloud Development Kit from AWS, and there's also Pulumi. And these tools try to use programming languages for you to describe your infrastructure and then also deploy it. In this talk, we're looking closer at the Cloud Development Kit, obviously. But the things you learn here and see, they are pretty much applicable to also other frameworks that have the same idea. So it should be helpful in any case. And as a small spoiler, the CDK is not just for AWS, it's also for other infrastructure. And I will talk about that very soon. So if you're just seeing, if you just saw and heard AWS and you're now starting to tune out, no, stop. This also works with Terraform and with Kubernetes, and I will tell you all about it in a minute. So what is the AWS Cloud Development Kit, or CDK for short? And I have to read this off here because it's really a mouthful. So take a deep breath. It's an open source, multi-language software development framework for modeling cloud infrastructure as reusable components. So the most important things here are, first of all, it's all open source. It works with multiple programming languages. You can see them here at the bottom right. So I think almost all popular things are supported here. So you can do Python, JavaScript, TypeScript, Java, C#, and Golang is also in developer preview. It's a software development framework. That means if you are a little bit familiar with one of those languages and you're writing code in them, you can use all the tools that you typically use to write that code. And that's the familiarity benefit that we see here. So you can choose one of those languages, your favorite languages, and it's just code that you're writing. No more YAML or other configuration language needed. You also get great tool support because typically what all of those IDEs can deal with pretty well is code, because that's their main focus, right? So you get things like auto-completion or inline documentation. And then here comes the modeling aspect. So now you're not writing a configuration language anymore. You're writing in a real programming language. And there, of course, you have ways to abstract things. So there are classes you can create, and those classes are part of the default library of CDK. And those libraries bring in a lot of smarts, a lot of intelligence and best practices that are already built in that you might not even know. And they will apply this for you automatically. And we will see in a minute what the benefit of that is. Finally, and that's an interesting also cultural aspect, is you can manage your infrastructure and code closer together, closer from a repository point of view, but also from your mind, from your thinking, because now you can basically build an app in one of those languages and use the same language to also define your infrastructure and use the same tools for linting, testing, and so on. So that's pretty cool. Now, as I already mentioned, there's not just the AWS CDK, which provisions infrastructure on AWS. There's also two other community projects which basically ripped out the core of CDK and used it in other environments. So there is CDKs, which is for Kubernetes. So there, you're writing, again, picking your favorite programming language. And then you are writing in that, and it turns your code into YAML deployment files that you typically use with Kubernetes, but you don't have to touch them yourself. The tool is doing that for you. And finally, there's also CDK-TF, which is the same thing for Terraform. So there again, you write in your programming language, and then it puts out Terraform templates that you can apply. Now, where do you find all that stuff? There's the so-called Construct Hub, which is a web page where you find additional libraries for all of those 3 variants of CDK. And it's a good place to just discover and explore libraries. So the community is contributing a lot of additional constructs, as we call them, so classes that do things for you, that build infrastructure, and you can find them on constructs.dev. Now, you might be wondering, okay, Robert just said something about constructs. I don't understand what's going on. So let's quickly talk about how CDK actually works under the hood. So first of all, you build what we call your CDK application. So that's just writing code in your programming language. And you can set up this CDK application with the CDK CLI. So there's a bootstrapping command here as well, a scaffolding command, which can set up the basic structure of your project, of your source code for that. And then you can start writing your own code to create your infrastructure. And in that CDK application, you can create a number of stacks. So that's a group of infrastructure that somehow is related. Maybe it's all the infrastructure for a single app. And then in that stack, you have the so-called constructs. And these constructs are basically the classes that represent the actual infrastructure. So in the case of AWS, a construct could be an S3 bucket. So there's a class that you instantiate to have an S3 bucket. Or it could be a database. And then there are constructs, as you can see here, that actually cover multiple resources at the same time. So they are already starting to pre-build larger pieces of architecture for you. And that's the thing that makes working with CDK so quick and smart. And we will see that in a minute. Now, once you've written your code, you use the CDK CLI as a kind of compiler because it synthesizes, hard word, synthesizes your code into a CloudFormation template. And that's like the way it works with all those CDK variants. It basically turns it into a declarative template as an output. So it's not reinventing the wheel. It's really using existing tools. And then it sends this template to the AWS CloudFormation service to actually deploy all your resources. And that's great because, as I said, it's not reinventing the wheel. It's not directly talking to the cloud. It's still using the CloudFormation tool. And you can even inspect those intermediate templates here. These are all valid CloudFormation templates. So if you have knowledge about that, you can look at them. You can still use linting tools and so on. So it's not a completely different thing. CDK is just augmenting or changing the way you produce these templates. You're not touching them themselves. You are doing it with the code you write here at the top, at the left. And that's really the paradigm change that I just described, where before with infrastructure as code tools, we have for some years now, you are writing this template in YAML or another configuration language, then you send it to a tool or a service that reads the template and then actually deploys your resources. And now you are using your CDK app that produces the template for you. So this is, you can almost ignore that as a step in between. You don't have to look at that stuff. And then you get your resources deployed in the cloud. Now, I talked a little bit about the power of those constructs, these classes that CDK has that represent resources and do a lot of smart stuff for you. So let me reiterate on that a little bit more. Generally, when we talk about CDK constructs, we categorize them into different levels. The level 1 constructs are the simplest ones, and these are automatically generated, and these are one-to-one representation of the CloudFormation resources that you might already use. So these classes are just one-to-one representations of all the services you can use in the cloud or in Kubernetes or in Terraform. So there's nothing special about them, no added logic or anything. Now, the second level constructs, this is where it gets really interesting, and this is what I'm going to show you in a minute. These are high-level constructs that still typically focus on a specific service, so on the VPC, on the load balancer, on the autoscaling group, but they come with a lot of intelligence and best practices built into them. So they help you to build better infrastructure out of the box, or better architecture out of the box. And they can help you, as I said, to make it easier and quicker to create well-architected, as we call it, infrastructure. Now, going beyond that, level 3 and higher, these are purpose-built constructs. So these would be classes that actually take a number of different resources and can basically be a complete architecture out of the box that where you just have to add maybe a few parameters. So if you think back on the web application architecture I showed you with a load balancer and the autoscaling group, that could be a level 3 construct where you just say instantiate Robert's highly available web architecture. And then you get all of that stuff. So that's a way to even go beyond the built-in stuff. And the cool thing is, if you build such constructs, that's just code. You can create it as a library in your programming language. And if you have an internal code repository or an internal registry for artifacts, like a Java artifact library or an internal NPM registry for node modules, you can basically put those constructs there and share them with your whole company. So that's also a way to scale your work and also improve company compliance, because you can build in all the configurations or opinionated stuff that you need at your company, and then you can share that construct with everyone else. So let's see how it works actually. So imagine, I'm not doing this live today, sorry for that. Imagine I'm opening my IDE, and I have initiated a new project with the CDK CLI. So I get a basic structure of files with which I can work. And then I open a specific file and I start coding it. In this case, I will be using TypeScript because that's my favorite language. And in fact, if you look at the Stack Overflow service, TypeScript is pretty popular anyway. So again, if your company is already using TypeScript, you can make use of a lot of knowledge if you're then also using creating infrastructure with TypeScript. So, and what am I doing here? First thing I do is I create the VPC construct, which is exactly what it says. It represents my VPC. So it creates a virtual network for you. And the interesting thing is, I will not read the whole text, but you see, as I'm typing, I get autocomplete, I get the inline documentation. So I don't have to jump to some web page to figure out what it is. It's built right in here, and I can see what it does for me. And it does a lot for me. So here's a bucket list, a shopping list of all the things that this construct does for me. So just to give you some examples, out of the box, it comes with a default IP range, so you don't even have to set this up if you need. It creates subnets in multiple availability zones. It creates private and public subnets. It sets up an internet gateway. It sets up the NAT gateways. And it does all the routing for you as well. So if you remember that, that box with all those things, we just did this with one line of code. No kidding. It's done. And that's the power of those level 2 constructs that I talked about. So this is a level 2 construct, obviously, because it does all those things without you asking for it. Still, there are configuration options, so you can change the behavior of that, or even go back in and rip parts out of it, or always go back to the level 1 constructs and build it from scratch. So you have full flexibility here. So now that we already have our VPC, let's now get to the autoscaling group. So that's step 2. And again, you see a similar pattern where we have a class that represents that autoscaling group, which is called autoscaling group. And this time we actually have to put in a few configuration options here. So we need to pass the VPC that we just created in the first step, and we need to define our instance type, because how should it know what instance type we want? And the cool thing we can do here is, as you can see, there are convenience functions and enums, so predefined values that are part of that library that make it really easy for you to find the right values, and at least find the correct values, valid values, which in my experience can be a problem with other tools where you basically pass in strings here and you can mistype them or they can change or whatever. And here it's basically part of the library. So as you're typing EC2 instance class dot, you get the list of all the enums that are there. You can select one and you can make sure that it's a correct enum that works in that context. So that's really great. And we see the same here for the rest of the configuration. So for the machine image, again, I have a convenience function here called latest Amazon Linux. So you can guess what it does. It takes the latest Amazon Linux. And you can pass some more configuration parameters. For example, in this case, I'm putting in the Amazon Linux 2 variant of that image. And finally, I also can, if I want, define the subnets in which the autoscaling group operates. And again, here I have a convenience function coming from the VPC where I can select the subnets I want to use. And as you can see here, and that's actually great, that code kind of talks for you. What do? I select subnets from my VPC of the type private. Because I want those VMs to run in the private network, because they are behind the load balancer. I don't want to expose them to the public. Now with that, we are already at step 3, which is configuring the load balancer. And it's the same pattern here. We have a class for the load balancer. We instantiate that. We give it some properties. Again, we're passing the VPC because the load balancer has to be attached to the VPC. We can define if it's an internet-facing load balancer, so if it should be available outside of our network, which in this case is true, right? We want to build a web app. And then we add, we call another few convenience functions. So we call add listener to say that the load balancer should listen on port 80. And then we call the add targets convenience function, which says, okay, if something comes in on that port 80, please also forward it to port 80. And the targets should be our autoscaling group. So that's the variable we defined one step earlier for the autoscaling group. And we're just referencing it here. Now, finally, we also need to make sure of security. I'm sure you, if you're dealing with infrastructure, especially in the cloud, I think everyone has that experience that you set something up and it's not connecting, not doing the thing, and typically that's due to security. So typically you forget to figure out what port to open, what thing to whitelist, what permission to give, because most of the things are like deny by default, and you have to selectively enable all the things. And CDK is helping you here as well. So you can see that there are convenience functions like this one, which is called allow default port from any IPv4. And it does exactly what it says here. It configures the security groups, the built-in firewalls of that load balancer. So that it can actually receive incoming traffic from any IP v4 address. And if you do this on your own, you can figure out how this works, but it can actually be tedious because it might not be just one place where you have to configure that to actually work. It might be multiple. And CDK is helping you with that and making sure it works. Now, one thing you might have already realized a little bit here is, and I think that's a big benefit. I think writing your infrastructure with code can give you the opportunity to write code that's better understandable, to write a story. You already have functions here that try to explain your intent on what should be done, which I think is a great way to actually transmit the meaning of what you're trying to achieve. And I think that's a super interesting thing because it's not just about code. Everything is about collaboration, right? So imagine a new team colleague comes on and he finds that, and he's familiar with the code, with the language like TypeScript here, and he can read this from top to bottom, and he kind of goes through a story of, oh, you create a load balancer, you add a listener there, okay, then you add the targets, then you allow incoming traffic. So I think it gives a lot of opportunity to make this a story which you can understand, and you might know clean code as one of the, like, I would say, reference books on that, on how this can be done, where I think Robert C. Martin, the author, and others at some point say, well, code is clean if it can be understood easily by everyone on the team. And I think that's the opportunity you have here with CDK for collaboration, to make that happen by writing code. And as it's code, you still have all the options you typically have when you write code. So you can create new classes, you can extend classes, you can create your own functions that speak to the reader and explain what they do. So all this is now available to you, and I think that's really interesting for collaboration. Now, to basically drive that point home that it just described, is like going back to the code. Like if we have this story of adding listeners, adding targets, doing things, transmitting intentions on what we're doing, I think it's much easier to create this image in your head on what's actually happening here, because you can read it and you get the story of, okay, my load balancer shall receive traffic on port 80 and send it to my instances in the autoscaling group. But what's actually happening behind that, and this is what CDK is taking away from you, is how the underlying, let's say, low-level objects in the cloud have to be configured to actually make this happen. And this picture above here, that's not some approximation or like stand-in picture. That's actually what's going to happen. So here you see nothing about the security groups that are involved in that. This is hidden behind this convenience function. The convenience function represents the intention to connect those things together, so it knows that it also has to configure the security groups, the firewalls, to make it work. And there are some interesting relationships between the security groups, because they also are kind of an identity. So you do things like, okay, the security group of the autoscaling group, it should allow incoming traffic from the security group of the load balancer. So this is really what's happening, but this is what you're describing. That's the story you're telling. And I think this is really powerful, that you don't have to think about this. Now, to have a wrap up here, I think we could end here with a little, let's say, comparison of those two things. So in the left corner, we have the proven champion, which is CloudFormation as that native infrastructure definition language, which is fully declarative, IDE support is hit and miss, and we saw that we need to write over 300 lines of YAML for my little practice infrastructure. And on the right side, we have the upcoming contender, which is the CDK app, which does abstraction via code, as we've seen. We've seen a lot of imperative aspects, so it's not fully declarative, right? You're calling functions, you can call them over and over, you can build in loops, you can add variables, you can pull data from anywhere that changes the flow of the logic of how your infrastructure is created or how much of it is created. So it's not fully declarative. And if you really like that style, then maybe you don't like CDK so much, which is totally fine. But the really powerful thing that I hope I've demonstrated to you is the built-in defaults and best practices you can get from CDK here to make it easier to write infrastructure and make it easier to write it with best practices. And in the end, if you've counted, we really wrote just 30 lines of code on our own. Of course, there's, I talked about the scaffolding, so there's more files, of course, in that project, but the stuff we really touched was just 30 lines of code, versus the 300 lines of YAML we had to write. So now you might ask the question, why should I code my infrastructure? And to sum that up, well, if you are familiar with code, if you are a developer or at least have some experience with a programming language, you can leverage your existing experience and use that familiar programming language to define your infrastructure. You also get typically pretty great support from IDEs because programming languages is like their first and foremost focus. So you get things like auto-completion and inline documentation, which help you along the way to write your infrastructure. And as we've seen, there are these powerful abstractions that help you to build smarter, faster. And what I think is really interesting, potentially more understandable infrastructure code that helps new team members to onboard quickly and understand the intention of what you're trying to build. And finally, I didn't touch so much upon that due to time constraints, but there's also the way to bring code and infrastructure closer together, right? So at least you have this idea of, hey, I write my app in TypeScript because I do Node.js and I have a React front-end app maybe. And then I also write my infrastructure in TypeScript and I have everything in TypeScript and all of my team knows TypeScript, so that's a great fit. Now you might ask, why should I not code my infrastructure? And that's, of course, a trick question, because at that point, you should know that this is the very best thing of how you should do infrastructure. There's no better way. No, just kidding here. Of course, there are reasons why you should not do it, or it might not be the right fit for you. So if you are more familiar with configuration tools like CloudFormation and Terraform, maybe you want to stick to them, and that's totally fine, right? Not everything has to be written in a programming language, in CDK or other frameworks like that. Also, if you don't like coding so much in general or like debugging stuff, maybe it's not the right thing for you because as you probably know, code and abstractions, so abstractions are great unless they don't work anymore. Right, and that's always the balance of abstractions. So they work great if they just do what you want, and there's no error and it works. But if there's an error, you might need to debug stuff, or you need to look stuff up on the internet. Why does it fail? That's this strange error message, and that's part of the course, right? This is nothing specific to CDK. That's just how programming, unfortunately, works a lot of the time. So if that's not your cup of tea, then maybe it's not the right thing for you. The good thing is you can do both. So you can use both config and code, mix and match depending on your use case, depending on the team. There are even features to import existing templates, declarative templates. So you're not forced to make a hard decision. Finally, here are some resources to get you started, and I will try to also post them in the chat in a minute, so you can just click on it. So there's the CDK online workshop, which is a great way to get started with CDK. You can choose your favorite programming language and just go along. And if you want to dive deeper, I've also provided here some links for diving deeper into CDK for Terraform. So that's when you're already using Terraform or you're not using AWS and want to provision a different cloud or different infrastructure, you can use Terraform. And then, of course, we have the CDK for Kubernetes, CDKs, which works with Kubernetes anywhere. So it doesn't matter if it's on-prem, doesn't matter what cloud, it works everywhere. And again, you can use programming languages. Yay. Then we have the constructs hub. I already talked about that. And then if you're curious to go a little bit deeper into this idea of bringing infrastructure and code together, there's a cool talk about CDK pipelines, which is one feature of CDK, specifically for AWS, where you can also code your CI/CD pipeline in the same programming language. So then you can basically have everything, the code, the infrastructure, and the CI/CD process in TypeScript, for example. And that's pretty cool. So that's it from my side. I hope you liked that session. I hope I could get you excited, and I hope you can now understand how I overcame my fear of the mountain of YAML by instead using CDK and programming languages. Thanks a lot.
Thank you, Robert. I definitely got hyped.
Cool, that was the intention.
Good, good. We got one question in the chat. Someone loved the screenshot of your IDE.
Thank you. Yeah, so full disclosure, I'm a pretty big fan of Visual Studio Code, which I think at this point almost everyone is. It's a great IDE. And that's what I use as my daily driver. And yeah, as I'm a TypeScript guy, that's obviously well supported in code. So that's where I do all my coding and, of course, all my CDK work.
Okay, thank you. I hope Mantas got the answer. Okay. There's still a few minutes, please. I hope to get a few more questions. In the meantime, I was looking at this and thinking, okay, it's kind of typical. If there's proper coding, then typically the next question is, where are some linters? What about testing of that code? Is that in a future program by Amazon Web Services, or something exists already today?
You mean specifically for CDK?
Yeah.
Yeah, definitely. So basically the main point here is in the end, you're just writing a program. So you can use basically any tool you like to do linting, to do testing. The library brings some testing functions with it, so some convenience function to figure out, did it do the right thing? But then for the test framework, you choose whatever you're already using for that language, right? I have nothing in my head, but there are so many test frameworks out there. You can basically use any of them because from their point of view, you're just writing code and you can do assertions and whatnot. So that's really easy to do. We're not AWS is not creating something new here, because the whole point is, hey, you're just writing code, use the tools you already have.
Okay, thanks. Well, since your very first slide mentioned Pulumi, someone made a question about that. Martin is asking, do you make any compare between Pulumi and CDK?
I didn't do it in this presentation. So I think the best way is to try both out to see the pros and cons. I would definitely say, especially if you are using AWS, the AWS CDK is a great experience that you should definitely at least once have checked out. And otherwise, I think it's really down to preferences. So there are some differences between those tools on how they work. And typically what we always advocate for at AWS is really, hey, it's so easy to try it out. Just download the code, create a test, a free account at AWS. Just use it. That's the best way to create informed opinion about how it works. So that's my suggestion. I know this is kind of a it depends answer, but I think in this case it's really valid, and it doesn't cost you much in terms of time to try it out. And by the way, I'm also try to, I need to put it in the public chat, trying to also put there the links that I'm showing on that slide, so it's easier for you to click on them.
Thank you for that. Unfortunately, we're out of time. There was one more question by Jonathan, and then maybe Jonathan can ask Robert directly in some chat or in some other way. Feel free to do that. I'm sure Robert is all in to answer all kinds of questions also offline. Thank you, everyone. See you in 5 minutes. We have the next talk. So a short break for now. Bye-bye. Thank you, Robert.
Bye-bye. Thanks a lot.